Okay, so as we are starting chapter 9, the first thing that we need to do is we need to review the Pythagorean theorem and the basic trig functions. And then you're going to have to be able to use that information to solve a right triangle. So let's just go through a few things that hopefully should be a little bit of a review. First of all is the Pythagorean theorem. Okay, we learned that in geometry last year and in Algebra 1 the year before that. So we have done the Pythagorean theorem before. And just remember that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. And of course, c is also the longest side. So first example we're going to look at is when you are missing the hypotenuse. So we would have a, b, and c. So our hypotenuse, remember, is always across from the right angle. So if we're going to use the Pythagorean theorem, we would say 3 squared plus 4 squared equals x squared. And when we combine 3 squared, 9 plus 16 is 25 equals x squared. And now we don't want x squared, we want x. So we take the square root of both sides and we get 5. And we don't need to worry about putting a plus or minus out in front of it because when we're talking about the lengths of the sides of a triangle, you can't have a negative side length anyway. So then the other type that you would look at would be when you're missing a leg. So if again, the legs make the right angle, here's your hypotenuse. So you would have x squared plus 8 squared equals 10 squared. So you'd have x squared plus 64 equals 100. When you subtract 64 from both sides, you'd get x squared equals 36 and x equals 6. So when you have a missing leg, it just adds one extra step in there where you have to subtract before you take the square root of both sides. Okay, so other than using the Pythagorean theorem with a right triangle, you can also use right triangle trig. Okay, trig is short for trigonometry, and there are 3 basic right triangle trig functions, which is sine, cosine, that should be a C-O, cosine, and tangent. Okay, and you can find side lengths and you can find angles using basic right triangle trig. One of the ways to remember which trig function is which with the side lengths and things like that is the acronym SOHCAHTOA, where S stands for sine, O is opposite, H is hypotenuse. So SOH, the sine of an angle, is going to be O over H, which is the opposite side length over the hypotenuse. And just a reminder that the angle is always attached to the trig function. So then if we were looking at cosine, CAH, that's going to be adjacent over hypotenuse. And then tangent is going to be OA, TOA, TOA, which is going to be opposite over adjacent. So let's take a look at how we can actually use that to find some side lengths. In order to do this, though, you are also going to have to be familiar with your Desmos calculator. And if you open your Desmos calculator, you will notice on your main screen that you have sine, cosine, and tangent right down here. So when we use those, we're going to have the sine, and technically it should be like the sine of an angle, which we'll call theta. That's what that means. But they don't put that in there on the Desmos calculator. So let's actually find some side lengths. Okay, so we are going to look at each trig function and just make sure we know how to solve with each one. So just a reminder that sine is opposite over hypotenuse. That sine is opposite over hypotenuse. And this angle here, that's called theta. That's just a variable representing an angle. When we start getting further into math, you'll start using Greek letters as instead of variables. You'll start using Greek letters like theta, beta, alpha, things like that. So if we wanted to find the missing side length, first thing we do is we identify, here is our angle that we're using, and then we look at the relationship with the sides. So over here, x is across or opposite from the angle that we are looking at. 18 is the hypotenuse, because the hypotenuse is always across from the right angle, and this side here is adjacent, which means next to. So if we look, we have information about the opposite side and the hypotenuse, which tells us we're going to use sine. So to solve this, we would say the sine, and then again, our angle is always attached to our trig function, so the sine of 58 equals opposite on top, which is x, over the hypotenuse, which is 18. Okay, and if you notice, now we just have an equation that we need to solve to get x by itself. To get x by itself, we are going to multiply both sides by 18. That will get x all by itself. So in our calculator, we're going to put 18 times the sine of 58, which is going to be 15.3. And we're going to round things to the nearest tenth. Okay, so that's an easier one when you have the x, notice, is in the numerator here, which makes our problem a little bit simpler. Okay, if we move down here, here is my angle. Okay, the 20 is opposite of it. The x is the hypotenuse because it's across from the right angle. This side here, which doesn't have any information, is the adjacent because it is next to the angle. So we know information about the opposite and the hypotenuse. So we are going to use the sine. And again, it's the angle is attached to the trig function. Opposite is 20. It's going to be opposite over hypotenuse. Notice this time that the x is in the denominator, which means we can't just multiply both sides by 20. We have to go ahead, multiply both sides by x, and that will give us x times the sine of 61 equals 20. Okay, well, we don't want x times the sine of 61, we want x. So now we are going to divide by the sine of 61 on both sides. So in our calculator, this is what we are going to put in our calculator, 20 divided by the sine of 61, and we get 22.87 or 22.9. Okay, so that's how you use sine. Now I'm going to go ahead and do 2 examples with cosine and 2 examples with tangent. Okay, so here is looking at cosine. Cosine, remember, from that previous slide, is adjacent over hypotenuse. So here's our angle. The x is the adjacent side. 18 is hypotenuse. Technically, this is the opposite side, but we don't need that. So we are going to say, since we know information about the adjacent and the hypotenuse, that tells me I need to use cosine. Angle is attached to the variable, or attached to the trig function. Adjacent on top, hypotenuse on the bottom. Again, all we have to do to solve that is multiply both sides by 18, put that into our calculator, and we get that x equals 15.74, or approximately 15.7. Okay, one more here. Same basic idea. Here is our angle. This side is adjacent or next to our angle. This side is the hypotenuse. We know information about the adjacent and hypotenuse. That tells me I need to use the cosine. Angle is attached to the trig function. And we have adjacent, which is 15, over hypotenuse, which is x. Just like before, x is in the bottom, so we have to multiply both sides by x. We get x times the cosine of 44 equals 15. To get x now all by itself, I need to divide by the cosine of 44. And I get, when I put in my calculator, 15 divided by the cosine of 44, I should get 20.85 roughly, which is about 20.9. Okay? If you want to pause the video and go ahead and try the tangent one, you can. Otherwise, I'm going to go ahead and do them also. Just the exact same idea. Tangent is going to be opposite side over adjacent side. So identify our angle. This is the opposite of our angle. This is adjacent to our angle. Of course, here's the hypotenuse, which we don't know anything about. If we know opposite and adjacent, that tells me I'm going to use tangent. So I have tangent of my angle, which is 53, equals opposite over adjacent. Again, to get my x all by itself, I need to multiply both sides by 16. And when I put this in my calculator, I should get 21.2 or 21.23 roughly. Okay, last example here where we are using trig to find side lengths. Angle, this is adjacent. This one is opposite. Again, this is the hypotenuse over here, but we don't need that. And so if we have information about adjacent and opposite, that means I am going to use tangent of my angle is opposite over adjacent, which is 20 over x. And just like you have in the other ones, you need to multiply by x and then divide, and you should get that x equals 36.08, or approximately 36.1. So this is how you use trig to find side lengths. Now we're going to look at how you can use trig to find angle measures. Okay, well, before we actually use trig to find angle measures, there is another way to find angles. If you are given an angle, this is still a triangle, which means triangles add up to 180 degrees. So if you ever are asked to find an angle and you know one of them's right and you are given the other one, you know that the three of them add together to be 180. So you know that 90 plus 41 plus x equals 180. That's what we call level 1 easy. Okay, and if we subtract those from 180, we get that x is 49 degrees. Okay, now let's look at level 2. Okay, level 2 is not as easy. We can use trig to find missing angles as well. So if we are given two side lengths of a right triangle, okay, so we know two side lengths of a right triangle, we can use trig to find the angle measure by using the inverse of the trig function. And on your Desmos calculator, the inverse of the trig function, if you go to your home screen, you have to click on the functions button. And if you notice, it will bring up the sine, cosine, and tangent with the -1 next to it. These are your inverse functions. And those are the ones that you're going to use to find angles. Okay, so let's take a look at how that actually works. Here I have two sides that are given, okay, and I have an angle that I need to know. Well, I'm going to call this angle x rather than question mark, because who wants to call it a question mark, okay? So here I have this angle. Step 1, I still identify my angle where it's at. Then I look at the information that's given. This over here, this side is opposite, and this side is the hypotenuse. Well, if we think back to our trig rules, SOHCAHTOA, sine, cosine, tangent, if we know information about the opposite and the hypotenuse, that tells us we are going to use sine. So we're going to set it up just like we have before, but I'm going to write it a little bit different. So we're going to have the sine of our angle. Well, our angle we don't know. Our angle is x, okay? That's going to equal the ratio opposite over hypotenuse. Well, our opposite side is 4, and our hypotenuse is 6. And if you notice right now, I'm leaving a little space here in front of the ratio for a reason, okay? So then I need to get x all by itself. So just like when you solve any kind of an equation, if you have 3x equals 12, you divide by 3 to get x all by itself, or if you have x plus 5 equals 2, you would subtract 5 from both sides. Those are inverse operations, which is exactly what we're going to do here. So all we have to remember is that we need to do the inverse to both sides, because whatever you do to one side, you have to do to the other. So I'm going to go ahead and take the inverse sine of both sides. What that does, just like division undoes multiplication, inverse sine undoes sine. So all you're left with is x over here, and you're left with inverse sine of a ratio over here. This is what you're going to put into your Desmos calculator. And remember, we already found where that inverse sine button is on our calculator. So you're going to put this exactly in there. So you're going to hit function, and then you're going to hit inverse sine, and on your Desmos calculator it'll bring up something that looks like this, and you just put 4 over 6, and it will tell you that the angle is, if I have the inverse sine, oops, daisies, of 4 over 6, that's going to be 41.8 degrees. Okay, so let's look at another one over here. Okay, here's my angle, that's x. Okay, well, over here is opposite. Here's my hypotenuse. Here's my adjacent. Okay, I always recommend labeling everything, The information we know is adjacent and hypotenuse. Well, if we have adjacent and hypotenuse, that means we're going to use cosine of the angle is going to equal the adjacent side over the hypotenuse. So we're going to have the cosine of our angle, we don't know that's x, equals adjacent, which is 36, over our hypotenuse, which is 51. Okay, and just like we did before, we need to undo cosine, so we're going to take the inverse cosine of both sides. And that gets rid of our cosine, and we're just left with x over here. And then in our calculator, we are going to do inverse cosine of 36 over 51. And when you put that in your calculator, you get that x equals 45.1 degrees. Okay, let's look at two more quick examples here. So we've got, here's our x, this is opposite, this is hypotenuse. Again, this is adjacent, but it doesn't help us because we don't know anything about it. We have opposite and hypotenuse. That tells me I need to use sine of my angle x equals opposite over adjacent. Okay, so the next thing, I need to take that inverse sine of both sides. That gets rid of sine, and I'm left with x equals the inverse sine of 45 over 49. And when I put that in my calculator, I get that it is 66.7 degrees. So if you want to pause the video and try the next one, you can go ahead and do that. I'm just going to tell you that x equals 44.1 degrees. So if you want to try to figure out which trig function it is and put it in your calculator, that is what you should get. And if you don't get that, then go ahead and come and ask me for some help, and I will be more than happy to help you. Okay, so what your homework is actually going to be is putting all of this together, okay? So when you put this all together, it's called solving right triangles. When you solve a right triangle, that means you find all the sides and all the angles. Okay, so we have to find all of them. Okay, so if you're finding sides, okay, well, in order to find sides, we talked about two ways to do that: the Pythagorean theorem and trig. Okay, the Pythagorean theorem you can use when you know two sides of a right triangle. You know A and B, or you know A and C. And then trig, you're going to use that when you know an angle and a side. So if you don't know two sides, you have to use trig in order to find the side length. Okay, and then if you're finding angles, okay, do you need to use triangle sum or inverse trig? That's the two ways that we talked. If you're going to use triangle sum, you do that when you're given a right triangle and know one of the other angles. So you have one missing angle. You know 2 out of the 3, you can use triangle sum. Inverse trig, when you aren't given any angles, only side lengths. That's when you have to use trig. And just keep in mind, if you use trig to find one of the missing angles, then to find the third angle, you can just use triangle sum. So you can kind of put all of this together. And as you're doing these, on your class kick, you're going to have to think pretty hard about which of these am I using? Am I using triangle sum or trig? When is it appropriate to use it? But you have time in class to work on it and ask for help when you need it, so please do that. And good luck.